In this video, you're going to learn about ionic and covalent bonding and how they share or transfer electrons through the representation of Lewis structure. Konnichiwa, what's up guys? So before we start, let us discuss first all the terminologies and concepts that we might use all throughout the video. So first, let's start with octet rule.
The octet rule refers to the tendency of atoms to prefer to have 8 electrons in the valence shell.
When atoms have fewer or greater than 8 valence electrons, they react and form more new stable compounds. They either share or transfer electrons. Second, valence electrons.
A valence electron is an electron that is associated with an atom and that to participate in the formation of a chemical bond.
Later, I will give you a tip on how to identify the valence electrons of every element. So make sure to watch this video to the end. And last, the Lewis structure.
A Lewis structure is a very simplified representation of the valence shell electrons in molecule. It is used to show how the electrons are arranged around individual atoms in a molecule. Electrons are shown as dots or for bonding electrons as a line between the two atoms. That's why it is also called as electron dot structure.
This is going to be the highlight of this video, so yeah. Now that we are done discussing the concepts, do you have any idea on what's the difference between ionic and covalent bonding?
Ionic bonding is a complete transfer of one or more valence electrons between atoms. It is a type of chemical bond that generates two oppositely charged ions.
In ionic bonds, the metal loses the electrons to become a positively charged cation, whereas the non-metal accepts those electrons to become a negatively charged anion. To better understand this, let's have an example. Do you see this salt? The chemical name for this is sodium chloride.
In this case, sodium is the metal while chlorine is the non-metal. Sodium, as you can see, has an extra valence electron, and in order for it to be stable, it needs to transfer that extra valence electron to any needing element. The sodium atom is donating its one valence electron to the chlorine atom. This creates a sodium cation and a chlorine anion. That's why chlorine is such a good soulmate, or should I say bond partner for sodium, because it exactly needs one valence electron for it to be stable. Do you still remember the octet rule? It tells us that an atom should have 8 electrons for it to be balanced. And now as you can see, they are both stable.
So before we start to another example which you guys are going to answer, I will teach you the tip that I've learned from my teacher on how to identify the valence electron of an element. First, you need to get your periodic table. The modern periodic table of elements consists of 8 groups. The first group has an extra of 1 valence electron. The second group has 2 excess valence electrons. The third group has 3 extra valence electrons. The fourth group has 4 valence electrons. The fifth group has 5 valence electrons. The sixth group has 6 valence electrons. The seventh group has 7 valence electrons, and lastly, the 8th column that has the complete set of valence electrons.
Try to illustrate calcium chloride using the Lewis dot structure.
Here is the answer. The calcium atom transferred its 2 valence electrons to the 2 chlorine atoms. Now, let's move on to the next type of chemical bonding, which is the molecular bonding.
Covalent bonding is the sharing of electrons between atoms. This type of bonding occurs between two atoms of the same element or of elements close to each other in the periodic table.
This bonding occurs primarily between nonmetals. Let's say we have phosphorus trichloride. In this case, the phosphorus atom needs 3 more valence electrons while the 3 chlorine atoms lack 1 valence electron each. For these elements to be stable, they need to share and pair their electrons to another atom. As you can see, the phosphorus atom is sharing its 3 unpaired electrons with 3 chlorine atoms. In the end product, all 4 of these molecules have 8 valence electrons and satisfy the octet rule.
Try illustrating H2O or water using the Lewis dot structure. In the octet rule, there is an exception, and that is the hydrogen atom only needs 2 valence electrons to be stable. As you can see, the oxygen atom shared its 2 valence electrons to the unpaired electron of the 2 hydrogen atom. Are they balanced now? Yes.
So, before we end this video, let us recap first what you have here.
Today we discussed about the 2 types of chemical bonding, which are ionic and covalent bonding.
Ionic bonding happens when an atom of a nonmetal takes 1 or more electrons from an atom of a metal, so both atoms end up with 8 valence electrons.
While covalent bonding happens when an atom of one nonmetal shares 1 or more electrons with an atom of another nonmetal, so both atoms end up with 8 valence electrons.
That's the end of this video. I hope you guys learned today, and I'll see you on to my next video. Ja, matane!